Assalamu alaikum. My name is Moaz Ahmed, and in this video, we will be talking about lab number 6, Introduction and Implementation of Timers and Counters on Atmega 328P using Atmel Studio and Proteus. The main objective of this lab is to introduce ourselves to interrupts, implement interrupts, timers, and counters on Arduino 328P or Arduino Mega 2560. So, first of all, what are timers? Timers are the heart of automation, and we have seen in previous chapters how we could take in an input, perform mathematical functions on the data, and perform an action. Timers are basically a tool for giving us an extra level of control by allowing us to control when it happens and how it happens. As we can use time delays or we can use time functions to make it happen something at a specific time or make it self-destruct, something like this. Timers are used for really important tasks like the task where we want a specific thing to happen at a specific time or after a specific time. Another concept that we want to get familiar with is interrupts. The program running on a controller is normally running sequentially instructions by instruction. An interrupt is an external event that interrupts the running program and runs a special interrupt service routine, which is usually referred as ISR. After the ISR has been finished, the code executes from the same exact line at which the interrupt was provided. So different modes of operation, it has different modes of operation: normal mode, CTC mode, fast PWM mode, and phase correct mode. So in this lab, we have four different tasks. First of all, let's move on to task number one. So So our task one is to write a program using a timer to generate a 500 Hz clear wave frequency on pin port C.7, then examine the frequency using oscilloscope, modify the count value to make sure that the frequency is exactly 500 Hz. So let's go to our code. So this is the code for task activity number one, and here we have defined the frequency and input output header file, and then we have defined the delay function. In delay function we have called tcnt is equal to 13130, and tccr0a is equal to 0x00, and tccr0b is equal to 0x04. So if I check my values, TCCR0A, so let's so here we are, TCCR0A, and here we can see that in the code TCCR0A is equal to 00, which means if the TCCR0A is equal to 00, this means WGM and has both values as 0, and if both values are 0, which means the normal mode is on. And next we have TCCR0B's value, which is set to 04, which means it is equal to 100. So I will go back to my code. I will go back to my circuit lab manual, and here we can see that if it is 100, that means CS2's value is 1. This line is being implemented, which means 256 is the prescaler for our code. And then we have the wait for overflow, and while TIFR0 and TOV0 overflow flag, which is overflow flag, is not on, it we want it to stay here, and when it turns on we want it to reset the flag and proceed. So this is the delay function, and in the main function we have turned the port C dot 7 to an output, and in the forever loop we have called the port C and turned its seventh bit to 1. Then we are calling a delay function which is right here, and we have discussed it previously. And after delay we want it to inverse the whatever the value was on the port C, and then we want it to again delay and then return 0. So this code will be implemented again and again and again as long as we want, because the forever loop is implemented. So if I go to my Proteus file, this is the Proteus file. So if I run the code, and so we can see here that it is showing us the signal on the oscilloscope. So if I change the values a bit, here we can see the signal as this one is as the value port C.7 is 1, and here port C7.7 is 0. And this value, the time it stays on, is the delay function. So that's it from this activity. So let's proceed to activity number 2, task number 1. And our task number 1 is, if I go here, our task number 2 is display the counting of TCNT register on LCD and also counting how many times the TCNT counter is overflowing and showing it on LCD. So task number 2 is right here. So we want to implement the counting function. So first of all, we have defined the port A as output and port C as output. Then we have initialized the LCD, and TCNT 0 is equal to 0x00, which means normal mode is on. TCCR0A is again 00, which means normal mode, and prescaler is being applied, and 0x06 it is. So if I go here back to the table, this one is implemented, which means external clock source on T0 pin and clock is on falling edge. So other than that, we have again implemented the while loop. While while it is not overflowed, we want it to stay in this loop, and we want it to display whatever the value is on TCNT 0. We want it to display on the LCD, and then we want it to shift 1 to the left, as after writing a number it automatically shifts to the right. And after the overflow flag is on, we want it to turn it again to 0, and we want it to reset it and exit the program. So if I turn on the file, this is the Proteus file. So if I play it, so we can see here that it is not showing anything. But as soon as I press the button, we can see here that it is incremented by 1. So here we can see that as long as the button is pressed, it will automatically keep on moving by 1. So this is our code, and That's it from this task. So let's move forward to our task number 3. Our task number 3 states that we are required to make a digital watch using timer. So this is the code for our digital watch. First of all, we have the similar code as before, delay. And in the main function, first of all, we have used the forever loops for each of our hour, minute, and seconds. And we have used the forever loop for each of their zeroth value and 10th value. So for int L is equal to 0, L is less than 3, which means we want it to stop at 24 hours. And then for int M is equal to 0 and M is less than 210, which means for minute, and L is equal to 2 and M is equal to 4, which means that whenever the hour is 24, as soon as hour becomes 24, we want it to break the code and exit. So this is the code right here. And if I go to my Proteus file and run it, we can see here that first of all it will initialize the clock and then it will start increasing the value. So this is the digital clock that we were talking about earlier. Now let's proceed to the task number 3. Task 4. Task 4 is count an external event that can be switched on and off and display on LCD or 7 segment. So in this code, first of all, we have defined the same old conditions. Initialize the LCD, then we have the while TIFR 0 and overflow condition. That as long as condition is not true, we want it to display the value, and then we want it to reset the value and turn off the flag. So if I go here and run this file, we can see that it will keep on increasing as long as this button is being pressed. If I remove it, now we can see that it is stuck at this value. And if I press this again, it will again start on moving. So this is the code that we have been talking about. And if I can just so if I just return back to my task number 2 again to run it again, and here we can see that it is changing the value and working perfectly. So that's it from this video. I hope you learned something valuable, and till next time, Allah Hafiz.